And go. So, a couple things first. You don't really need to write this down if you're taking notes. Maybe if you really want to, you can write like this down right here. Basically, what all these words say, I'm not gonna like read it verbatim, is if we have a polynomial f of x, so maybe this right here we can call f of x, what's under this dividend here, and we divide it by something. We divide it by d of x, so right here this would be d of x. If we divide it by d of x, then we're going to get this q of x up here, right? Then we're going to get another polynomial up here. So if we take a big polynomial, divide it by a smaller polynomial, we'll get another polynomial. And what that means is that this polynomial and this polynomial multiply together to get this, right? Just like if you divide 12 by 4 and you get 3, that means that 3 times 4 equals 12. That's all this is saying in polynomials. But when there's a remainder, like in this one, 3x minus 8, you can slap it on to the end. We were used to doing like a plus 3x minus 8 all over that stuff, all over this, right? But there's another way to do it where you write these two things multiplied together, and then you just add on the outside this, right? So that doesn't really tell you what the division is, but what it tells you is that your original function equals those two things multiplied together plus your remainder, which seems weird, but it makes sense, and I could show you, if we had more than 25-minute class periods, I could show you a lot more easier, and you go like, ah, yes, that's why you can just add that on the end there when you represent it like as this thing plus this thing. But maybe a better way to do it is if I just did it with a number. So maybe let's do like, let's do 24, and if we divided 24 by 5, right, 4 would go here, then you'd get 20, subtract it, and you'd have a remainder of 4, right? So that tells us that 24, what's underneath, right, is equal to 5 times 4, these two things, plus the remainder 4. And hopefully that kind of clears it up. Right? Everything with an x or variables are just numbers, so they follow the same rules, right? Now we're just dealing with entire polynomials. These were the two things, right? Multiply them together, and if you add that, you should get what you divided, right? So it's the same idea, and that goes into this. So this is what you do want to write down, or maybe snap a pic of or something. So if the polynomial f of x is divided by x minus c, then the remainder is f of c. What does that mean? Well, maybe I'll do an example first, and then I'll come back to this and show us why it makes sense. But I'll give us a second to write this down. Okay, I think we're probably good. If not, I can go back. Well, I will go back later on. So if f of x equals 2x cubed minus 5x plus 4, then what is the remainder when f of x is divided by x minus 7? So back here, x minus c, we have to evaluate f of c. So here, c is 7, right? Because it's minus c, so minus 7, c is 7, right? It's basically the opposite of what this is. So if it was plus 7, this would be negative 7. So all we do is evaluate f of 7, which if we look back up here, it's going to be 2 times 7 cubed minus 5 times 7 plus 4. 7 cubed, I don't know what that is. Too much is what it is. 7 cubed is 343 times 2. I could probably do that in my head, but who cares? 686. So 686 minus 5 times 7. 35 plus 4. And then, so that's really 686 minus 31. So 85, 55, 655. And so what that tells us is that our remainder is 655. Right? What is the remainder? There it is. That's from the remainder theorem. Literally all you have to do is evaluate C at here. And it seems magical, right? Like, why the heck does that work? And sure enough, if you were to do x minus 7, or hey, let's even actually let's do synthetic division, right? Let's do it really fast. Remember, what would go here is 7, and then 2x cubed. We have 0x squared, negative 5 and 4. And we can do synthetic division really fast. We bring the 2 down. 7 times 2 is 14. Add them. 7 times 14 is going to be 70 plus 28. So 98. This is kind of gross, but add them is going to be 93. What's 7 times 93? 651. Oh, and add them. Look what our remainder is. 655. It checks out, right? And so now let's go back and think of why. Okay, so if we have f of x and we divide it by something, in this case we did x minus 7. We could think of this as x minus 7 and the whole thing. We know that that's going to churn out from back here, right? If we divide something, we spit out, two polynomials, this polynomial times this polynomial plus a remainder. That's what the whole point of this was. If you divide a polynomial by another polynomial, you get that polynomial times another one plus some remainder. Okay, so if we start with this polynomial and we divide it by x minus c, right? We divide it by x minus c, then that means that x minus c times some other polynomial, maybe call it q of x, whatever it is, doesn't matter. And then we have plus some remainder r of x, some other polynomial. But here's the thing. It's not going to be r of x. It's just going to be r. It's going to be a constant. And how do we know it's a constant in this case? Well, if we divide by a linear term, x minus c, right? If we were to do the long division here, x minus 7, we did the long division all the way down like we did on, or like I did on this one. Our remainder, if we divided by something that just had an x, our remainder would be a degree that's less than x or a constant, right? Because if this was just a linear function up here, if this was just x and I had an x here, I could make it match and I could go one more, and then the remainder would be a constant. So that's the reason we know that this is just a constant. And so why is the remainder as simple as just evaluating it at c? Well, what happens if we put in f of c? F of c equals, maybe we can see where this is going, c minus c, right? You're putting x in for c, times q of c plus r. Well, c minus c is 0, and 0 times anything is 0. So we get f of c equals r, the remainder, right? And that's all this is. You plug it in, you get the remainder. So it only works when you're dividing by this linear x minus c term. Just like synthetic division, also only works if you're dividing by an x minus c. So let's do one more example. So then what is the remainder when f of x is divided by x plus 1? Well, c is going to be the opposite, so negative 1. So all we have to do is do f of negative 1, which equals negative 1 to the 6th plus 3 times negative 1 minus 1. Negative 1 to the 6th is going to be a positive 1, right? Negative times itself an even number of times is going to be positive. 3 times negative 1 is going to be minus 3 minus 1. So f of negative 1 equals minus 3, right? Cancel minus 3. And so the remainder is negative 3. It's that easy.